Hi, could you please introduce yourself to us and briefly describe your research to start off?
Sure. I'm Dan Tamayo. I started last year here as a Prof at Harvey Mudd, and I study exoplanets. So these are planets that we're finding around other stars. Right, for all of human history, we had one solar system to look at, which was our own. And starting about 25 years ago, we started finding ones around other stars. Now we know of about 1,000 planetary systems. And it's the first chance, right? Like, we're the first people that get to look at what other solar systems look like. And that's been full of surprises, right? Like, some planets we find really close to their host stars. Our solar system planets are on nice circular orbits. Others are on extremely elliptical orbits that bring them screaming by the host star. They're thousands of degrees. Some of these are lava worlds where their clouds are made of like vaporized silicon rather than water. These are right size, really bizarre places. So our research is centered on trying to understand what goes into that process of planet formation. We get to play God and make lots of planetary systems and put different physics into those simulations, and then compare the outcomes to the diversity of planetary systems that we see around other stars to try and understand that planet formation process and put our own solar system into context. So that's a blast.
Can you tell us a little bit about how you first got into physics?
Sure. I guess I always liked math and science in high school. In college, I started in computer science, but then got frustrated debugging, trying to find, like spending hours trying to find semicolons. So I decided to switch into physics. And now I spend all my time programming and looking for semicolons, doing physics. I thought after undergrad that I actually didn't want to do physics. I wasn't sure about what I wanted to do. And then I spent 2 years in the Peace Corps teaching in a small village in Namibia, math and science. And there, the topics that were always the most fun for me and for students was talking about astronomy and other worlds, other stars. And that's when I realized that astronomy really is physics, but applied to really big things. So that got me interested in astrophysics, and from there I applied to grad school and eventually found my way here.
And our very last question is, do you have a favorite fun fact?
So my favorite fun fact about physics and astronomy is that there's a really interesting property of Newtonian gravity, that it goes as gmm over r squared. And that squared turns out to be really interesting, because if you look at Newton figured out that gravity gave you elliptical orbits, and because of that 1 over r squared, it turns out that when you get an elliptical orbit, it stays fixed in space. If it was anything other than squared in that denominator, the orbit would just continually rotate. So there's a really special symmetry in that two-body problem that comes from gravity being a 1 over r squared law. And it turns out that the fact that the planet orbits don't rotate, that allows different planets on different orbits, because they're fixed, to give each other really coherent torques that build up over time. And that leads to big oscillations in the orbital eccentricities of planets that contribute to ice ages on the Earth. And the amazing thing is that same symmetry also shows up in the hydrogen atom, because the electrostatic force also goes as 1 over r squared, so it has the same symmetry, and that causes the energy levels in the hydrogen atom to be degenerate. So it's amazing that this, this funny mathematical symmetry gives you something really fundamental that shows up in quantum mechanics and in the ice ages on the Earth.